Assalamualaikum and hi, welcome back. Now we're going to continue on the gravity retaining wall, example 7. The masonry dam whose cross-section is shown in the figure retains water against its vertical face. Meaning here, there is a water. Examine the stability condition of the dam with respect to 1. Tension in a joint, 2. The ground bearing pressure, 3. The overturning, and 4. Sliding. Meaning you have to check the stability with respect to this. And given the unit weight of masonry is 21.6 kN per meter cube, meaning this is the unit weight of the wall, and angle of wall friction is 30 degrees, meaning this is delta. Here, I create a table because we know that the first thing to solve the stability problems, we have to find the vertical forces and horizontal forces. For vertical forces, we have to look at the cross-section of the retaining wall because the vertical forces, as I have explained previously, it is in regards to the weight of the wall. For this one, let's look at how am I going to divide this cross-section of the retaining wall to make it easier for us to calculate the weight. Right, so I divide it like that so that's lebih senang untuk kita dapatkan the value of the center of gravity, W1 and W2. I'm going to look at W1 first. This is the triangle and we know that the length of this is 1.8 meter because 2.7 meter minus 0.9, it is 1.8. So let's go back 1.8, 4.2. Therefore, the area of this triangle is 1/2 darab lebar 1.8 dan height dia adalah 4.2. And we know that this is the unit weight of the retaining wall. Sebab kita nak dapatkan berat dia kan, therefore, supposedly the unit weight ni adalah 21.6 kilonewton per meter cube. Meaning 1 meter cube of the wall, berat dia adalah 21.6. For our retaining wall sekarang ni, this triangle, kita nak tahulah berapa sebenarnya dia punya volume. However, since the retaining wall ni, kita akan kira untuk setiap 1 meter meaning that dia memanjang ke sana lah. Okay, so 1 meter. Okay, ini kita tak count So, kita just ambil the area sahaja. That's why dia jadi per meter dekat sini. Ini area dia dan darab dengan the unit weight. Then we get 81.648 per 1 meter length of retaining wall. We have to also calculate the moment. Why? Because kita nak dapatkan the stabilizing moment. Because of the weight of the wall helps to stabilize the retaining wall. Here, kita akan ambil daripada point A. Which one is point A? Point A is definitely the one yang in front bukan dekat side yang retain material. Side yang retain material berada dekat belakang ni, kita namakan dia B. So yang depan ni yang tak ada kena-mengena dengan retain material, we call it as A lah. So kat sini lah selalunya wall tu akan overturn. So untuk our first triangle here, we need to get what is the distance daripada centroid to point A. Meaning this L1 So as we know, if triangle doesn't matter, kalau kanan dan kiri, so obviously the area untuk triangle tu belah kanan lebih besar, meaning that the center of gravity akan lebih ke arah kanan, dan we know that this one is 2/3B and this one is 1/3B. And since point A dekat sini, right, so jarak dia adalah 2/3 times B. Then it is 2/3 times 1.8 meter. There you go. Next, kita akan kira the moment about A, meaning that moment we know that the force you have to darabkan dengan the distance, right? So the force ataupun weight dia adalah 81.648 times with the distance 1.2, then you get this 97.978. Now let's look at W2. For W2, the area would be 0.9 meter darab dengan 4.2 meter. This is just a rectangle. That is the area. Then kita darabkan dengan the unit weight of the wall. Sebab ini kita nak kira berat wall. Then we get the 81.648. And how about lever arm from A? For lever arm from A, look at L2 here. It means that, okay, we have half of 0.9 here untuk sampai ke A. Dan dekat sini kita ada 1.8 meter. So just add these two together. That is the distance untuk pergi ke A. Sebab dia akan pusing macam ini ya. Isti 90 darjah. Sama juga untuk W1 pun 90 darjah. Dia punya distance nak ke point. Which point? Point A. Then I dapat 2.25. Darabkan saja the weight with the distance. You get 183.708. And kita akan total up the RV ataupun the vertical forces here. I get 163.296. Just add the two together. And for the stabilizing moment, 97.978 plus 183.708, I will get 281.686. Right, so that's all about the vertical forces and stabilizing moment. Total MS. Next, we're going to look at the horizontal forces. What is the horizontal forces here? What is the lateral thrust here? It is water, that the retained material. Have a look at this one. So for water, the pressure distribution going to be increase uniformly like this, meaning dia akan jadi macam segi tiga untuk water ya. You know that the value here is going to be, because this is water, unit weight of water times with H, ataupun the density of water times G and times H. Doesn't matter at this point here. The maximum value of the pressure. Paling bawah dia lebih paling maksimum lah. That's why bila kita calculate the total pressure, meaning that kita akan kira the total area of this triangle. Okay. So we know that ini adalah H because of the water reach the very top level of the retaining wall. The pressure is going to be half times with the width. Kalau kita pakai unit weight water, okay, darab dengan H, darab dengan H. Therefore, we get half times unit weight of water H power of 2. Or, if you use the density instead, half times density of water times G times H, darab lagi dengan H lah. Right? Sebab kita kira area dia kan. Therefore, become half times with density of water G H power of 2. Depends on which one you're going to use. Because according to the question, dia tak ada mention whether dia bagi unit weight of water, tak ada. Density of water, tak ada. So you are free untuk pakai mana-mana because we know that unit weight of water memang fix 10 kN per meter cube. And kalau density of water adalah 1000 kg per meter cube. Up to you which one you're going to use, tapi I usually pakai the unit weight lah, 10 kilonewton per meter cube. I write here PA which is the active lateral thrust ataupun active lateral pressure. Kenapa active? Because of they actively try to overturn the retaining wall. So any forces yang try to overturn the retaining wall, kita panggil dia as active lateral pressure, PA. Okay, so half darab dengan, as saya dah tulis dekat depan tadi, unit weight of water times with H power of 2. Like this one. Unit weight of water is 10 kilonewton per meter cube fixed. And the height of the water, bukan height of retaining wall. Kita akan tengok water tu sampai mana height dia. And since dalam soalan memang kata dekat paling atas, meaning reach the top of retaining wall, meaning it is 4.2 ikut height of retaining wall. Therefore, I get 88.2. And we need to find the overturning moment. Therefore, kita perlukan distance. Sebab force kena darab dengan distance baru jadi moment. And because of this is lateral force, meaning horizontal macam ini. Okay, so jarak 90 darjah sebab dia nak pergi macam ini. Daripada centroid dia akan pergi ke sini lah. Okay, jarak dia mesti 90 darjah dengan dia punya force. Meaning, okay, force dia arah macam ni, jadi dia 90 darjah. So, you perlukan jarak yang ini. And since kita tahu kalau segi 3 pun sama, atas dan bawah kita tengok. So, bahagi 2. Belah bawah ni, kita nampak dia lebih banyak triangle punya area. So, dia akan turun ke bawah lah. Right, so bawah ni akan jadi 1/3 H dan atas ni akan jadi 2/3 H. And since kita nak ke point A, so 1/3 darab dengan H. That's why jadi H/3 here. Right, so here I dah darabkan 1/3 times the height of the water, then I get 1.4. Darabkan saja the RH, the PA, with the lever arm from A, then I get this value, and then sumkan the horizontal forces, you get 88.2, and the overturning moment, that's the only moment that ataupun horizontal forces yang kita ada, it become 123.48. Done with the forces and moment. Now we're going to solve this stability calculation. First, kita kena cari the position of ground reaction. It is X. So this one, actually I have explained in our previous recorded video. This is the formula that we're going to use. So X ini adalah position of ground reaction. The base length minus dengan the total stabilizing moment minus with total overturning moment divide with vertical forces. All this value kita dah ada. Okay, the base length is definitely 2.7 ya. So ini adalah base length 2.7. And we have the stabilizing moment which is here 281.686 and overturning moment 123.48 and total vertical forces 163.296. Just fill in into our formula here that I get 1.731 from point B. So where is point B? It is here. So the position of ground reaction X berada di sini lah. Okay. Daripada point B. We need to check if there is tension in a joint or not. Okay, how are we going to do that? Kita akan gunakan middle third rule. We know that this is 2.7 meter with bahagikan kepada 3. Okay, start from A and B, 0 at B, 0.9, 1.8 and 2.7. And since the X ataupun position of ground reaction is within middle third, Di mana middle third? Middle third adalah di tengah-tengah ini. And the position of ground reaction would be 1.731 meter from B. Okay, jadi kita nampak dia memang masih lagi berada dalam middle third. Therefore, the middle third lies between 0.9 and 1.8. We explained a bit. And the resultant force ataupun position of ground reaction cuts inside the middle third, berada dalam kawasan middle third. Therefore, no tension in the joint will develop. That's what we found. So, dia tak ada masalah dengan tension in the joint. And because of the within middle third, we know that the formula that we're going to calculate for the ground bearing pressure going to be this one, as I have explained in our previous video. You can refer to the formula here. This one, if it is within middle third, then we're going to use this formula to calculate the ground bearing pressure. We have QA and QB, V over B plus minus 6VE over B square. We have the value of V, which is the RV. We can refer here 163.296. Divide with the B, which is the base length, 2.7 meter plus minus 6 times RV again. Take the value of RV times with VE. And VE, in this case, it would be X minus B divided with 2. X is 1.731 minus with 2.7 meter bahagi 2. You will get 0.381 meter. That is the eccentricity, and divide with B square. For QA, it will be 60.48 kilonewton per meter square plus with 51.206 kilonewton per meter square. And for QB, it will be 60.48 kilonewton per meter square minus 51.206 kilonewton per meter square. That is the value. And if you need to draw the ground bearing pressure distribution, so this is B and this is A, this will be 111.686 kilonewton per meter square and 9.274 kilonewton per meter square. That is the value for ground bearing pressure, and this is how the distribution looks like. This question, dia tak minta you check meaning dia tak bagi safe ground bearing pressure, tak ada, ataupun allowable ground bearing pressure. Therefore, kita just leave the answer like this. Next, the question asks you also to find the factor of safety against overturning, because the question minta you check the stability of retaining wall against overturning. And we know that the formula for overturning is total stabilizing moment divided with total overturning moment. Masukkan saja the stabilizing moment, which is here, and overturning moment, which is here, then you will get your answer 2.281. And leave it like that. Tak ada comparison yang kita perlu buat. Next, we have to find the factor of safety against sliding. Mu RV divide with P. Okay, ataupun mu V bahagi P. Sama saja. P ni apa? RH lah. Mu is, we have to refer to our question, whether mu is given or not. Okay. Okay, since in this question, dia tak bagi mu, but it just that dia bagi the value of delta. And we know that to get mu, you have to take the value of delta and tangentkan dia. Right. So, mana formulanya? Di sinilah mu sama dengan tangent delta. Tangent 30 darjah, it becomes 0.577. That is the value of mu. And the value of RV, ambil saja di sini, 163.296. and the value of P or RH is 88.2. Sinilah. Okay, so selesaikan, you get 1.068. Leave it like that. We don't have anything to compare. Siaplah our example number 7. See you in the next example. Bye.